start recording, otherwise I'm going to forget. Eliza.
I'm here.
Hey, Eliza. Bree is here, or at least she was. Bree. Where is Bree? Bree, are you there? I think that's her there in the square, but okay. Grace D.
All right.
Here.
Hey, Grace. Greg D. Sorry.
Here.
Emily.
Here.
Olympia.
Here.
Jenna.
Here.
Daniel.
Here.
Greg M.
Here.
Ashley.
Here.
Kyle.
Hello.
Saga.
Here.
Ada. Okay. And Elizabeth was just here, and Mary Pat.
I'm here.
Okay. So it looks like we're just missing Cole. Did he come in while I was taking roll? I don't think so. Okay. So let's talk briefly about, let's see here. We have an exam coming up. Oh, that's not the right class. Hold on. We still do have an, so next week is the exam. Hopefully that is not a surprise to any of you, that you've been studying and getting ready for it. So today's class on sampling is going to be the last lecture that we have that'll be covered on the exam. So just let me know. Oh, Elizabeth, now I'm curious. Are they all okay?
I think so. I think they're fine.
Okay.
Like, it was a fender bender.
Oh, still, that's annoying. Okay, so today is the class, the lecture that's going to be the last new topic that's covered before the exam. Next week, come to this class, the regular class time. We are going to all meet for Zoom real quick. I'm going to go over some instructions, and then you will start the exam from that period on, like at 2 o'clock. And then make sure that you submit it no later than 5 o'clock, when is the end of our class. So you get the 3-hour block of time, which should be more than enough. And you'll see at the very top of the exam, there's going to be my phone number. So if you have any questions, imagine if we were in the class together and you had a question, you'd raise your hand, I'd come over. You can make sure to text me if you have any questions during that time, and then I'm happy to answer questions that I would normally answer if we were in the class. And Cole, it looks like you're here. Hi, Cole. Mark you. Okay, so any questions about the exam?
How many questions are you thinking that are going to be on it?
I don't know how many questions per se. I feel like I think it's around 15, so not that many. 1 hour should be more than enough to complete it, but I learned this actually with my other class last week. They had their exam, and I was like, it should take you like 40 minutes, and they're like, are you crazy? So maybe my estimate of time is not spot on, because of course I write it, so it makes sense to me. I know the answer. But you will have more than enough time for the 3 hour, like the whole amount of time that you have set out for the class is more than enough. So again, remember to come in, log on to Zoom. I'll give some quick instructions, and then you go ahead and get started on your own. We'll stop Zoom. I'm not going to be staring at you guys taking the exam. And then just make sure that you submit it. It's going to be like an assignment, so you can submit it, and then we'll be done for the day.
So, with the test, like when I'm looking over our past lectures, I like find that I'm taking some notes, but there's, is it going to be more like what we've done for the past couple tests where they've got like definitions and then some equations?
Yes. That's going to be
Okay.
spot on that. So it's going to be far more application-based questions where you're working through some of the formulas like you just said. It's going to be more like that than just straight memorization. I don't find that to be very useful for statistics. But there are going to be some more concept questions.
Okay.
So
and then-
just like we've had in our quizzes.
Okay, and then with the labs, are we going to be asked to like go on Excel and make some things?
Yep, so there's going to be two parts to the exam. There's going to be one part that's going to be in Word where you're going to be writing things in.
Okay.
Or if you want and you want to draw something and then take a photo and upload that as well, that's totally fine, especially with graphing. Sometimes the goal of the class is not to test your ability to graph using Word. That's not the goal. So if you want to just draw, that's fine too. And then there's also going to be an Excel spreadsheet where you're going to have to do some manipulation.
Okay, the problem that I'm running into with the free version of Excel is like I saw that you had to like get a subscription in order to like save your material and stuff. I don't know if someone else found that. That might just be a me problem, but
The other way to do it would be to print it as a PDF
okay,
and then save that.
got it.
That would be another way to do it because I don't need to have it back in Excel. I can grade in non-Excel. Does that make sense?
Okay, thank you.
No problem. All right, so let's dive in for today. Okay. Whoops, not design. I always hate how the Zoom thing, there we go. I'm beginning. Okay, and you guys can all see my screen? Okay, so today we're going to be talking about sampling distribution and and how that works specifically when we are doing research. So some of the objectives for today, we're going to be looking at the aims of sampling, and specifically we're going to start discussing probability and probability theory. We're also going to talk about different types of sampling design and sampling distribution and how those relate to the central limit theorem, which we've been talking about all along in terms of normal distribution, kind of a, that normal curve, bell curve data. Okay, so why do we sample, right? What's one of the reasons you guys can think of why it's helpful to use a sample rather than a population?
It's much more convenient.
Way more convenient, right? Because if I take an entire population, and in fact, we are seeing this is a year where the census is being done. It's a huge headache, right? People are trying to get every single, like a record of every single person, which is very, very challenging. So a population, this is a quick reminder, we've discussed this before, but a population is a group that includes every single case that the researcher is interested in. So it's either individuals, objects, groups, right? So you can look at the entire world, or if you're interested in men, every single man, or if you're interested in the entire college, right? It would be all of Aquinas. If I do a sample, that ends up being a smaller subset of that population. And the idea behind it is if it's a randomized sample, then somehow the group that we get that's kind of randomly selected should be a good representation or should generalize out to the larger population at large. So if I'm interested in how college students study, I could ask every single student at Aquinas about their study habits, or I could take a general sample across all levels, all majors, men, women, all different groups, right? Get a randomized sample and ask them about their study habits. And then from there, I can generalize to the entire population, right? So again, if I'm interested in all of Aquinas's college freshmen, this was I think that was last year's number. It was 179. It's a little different this year, especially with COVID thrown in. But I could ask all 179 freshmen about their freshman experience, or I can grab a subsample of 30 students, which would be a lot easier, and say that that generalizes over. You can see again, people in Grand Rapids versus Michigan, Canadians or Americans, women, you know, so all of that will make a difference. But you can see if you're able to take and I'm using this keyword a lot, ding, 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 let's remember to use that too. If it's a random sample, meaning I did not select certain people specifically, but I randomized it, then I can infer some level of generalizability to the whole population at large. So one of the main reasons why we do this is because getting an entire population, as Kyle said, is really hard and it's really time consuming. So there's rarely enough time or money to collect the data from all of the people in a given population. So we take a subset so that it is meaningful again. So again, you could see this is the population, is the score of all Canadian women and the sample of the scores of the 50 Canadian women studied. So you could see here, the curve is mimicked, right? This is an entire population versus this is a small subsample, but you see how it's behaving the same way. Same here. So you get to a certain point where the size of your sample is large enough that it is representative of the population at large. Okay, so when we look at sampling, right, which is what we're going to be doing, and frankly, if you're ever involved in research, that's what you're going to be doing as well. This is the nomenclature that you would use. So a parameter is a measure, for example, a mean or standard deviation, that's used to describe a population distribution. So parameter is tied with a population, whereas a statistic, such as a mean or standard deviation, is used to describe a sample. Okay, so main difference. When you're dealing with the population, you talk about parameters. When you deal with samples, you deal with statistics. Okay, and this is the nomenclature that's used. We've talked about this already in our class. Those are the Greek letters that are used to show, you know, for samples versus population, the different parameters and statistics. Okay, so this is just good for you guys to know. All right, so again, our population here, this would be all of these individuals. I can grab a just, you know, random sample of them that you can see here. And from there, I could run some analyses, right? So with the population, a parameter would be the proportion of white respondents in the population. So I would get this, that would be the parameter. The result would be 0.6. Whereas if I have a sample, I can do the exact same thing. I can run the statistics on that, or what is the proportion, and it's 0.67. As you can see, the two are very similar, which is why we can generalize from a sample. So that's this. Oh, go ahead.
Sorry to interrupt.
It's okay.
But, so just thinking more about the random sample, kind of backtracking a sec, are we going to need to explain a method to make it random? If that's in the exam, quite possibly, because I know there are so many different types of samples.
Mm-hmm.
I don't know how to make it completely randomized.
We will definitely talk about that this semester, the different type of sampling method. And a quick way, just so you know, a quick way to make a random sample is if you know you're going to be reaching out to, you think you need about 50 people, for the sake of argument, that we're looking for freshmen, right? Freshmen at Aquinas. I have a total list of the freshmen at Aquinas, right? I can ask the registrar, and now I can say out of the 179 total, I want 50. And you can go online and say random number generator, select 50, and it'll give you random numbers between 1 and 79. It'll give you 50 of them, and you pull out those 50. That would be random sampling.
Okay.
What would not be random sampling is standing outside of, I don't know, is there a coffee shop on campus? What is it called? The Moose? Yeah. If I stand outside there and I'm like, are you a freshman? No, you're not. Are you a freshman? Oh, you are. Okay, take this survey. That is no longer random. It's called really a sample of convenience. It's convenient sampling because you are parking yourself here. But one might say that there's something about folks who go to coffee shops that in and of itself, I've just skewed my sample, that they're a different breed of freshmen, right? Maybe that speaks to how much money they have, or you know, their health habits, or maybe even their schedule, right? If they're in a coffee shop in the middle of the day, maybe they don't have to have a job, right? So that would, a sample of convenience takes out the randomness of it. Does that kind of help what you were
No, yeah,
asking?
no, yeah.
Okay.
Thank you.
But we'll talk more about distributions as well. Not distribution, sampling. Again, I'm on some cold medicine, so sorry. Okay, so probability sampling. Let's talk about that first off. So the goal, again, is to obtain a population parameter. But because we're not able to test everyone, no one has the time or money to do that, then you grab a subset of that population or a sample and you create statistics from it. So a probability is the quantitative measure about the likelihood that an event will occur. What is something that you guys can think of when I say probability? You're like, yep, I am thinking of this example, and that's based on probability.
Winning the lottery.
Winning the lottery, great one. Somebody else.
Gambling or playing games like that, like card games or dice games.
Totally, Greg. Yeah, anytime you think of Vegas or casinos, you're looking at rules of probability. Yep. Any other idea comes to mind?
Getting into college, a college.
Yeah, talk about the probability of that for sure. Or you hear about like getting struck by lightning or probability of a plane crashing. Anyway, let's not talk about negative things like that. But you know, those are things that, and oftentimes when you're exposed to probability, it's in high school, and there'll be the idea of let me grab either a card out of a deck or roll dice, right? And you talk about the probability of getting a certain event out of the entire realm of possibility for all events, right? That's usually how we think about it. So when we use probability sampling, it's a method of sampling that allows the researchers to specify for a specific case in the population. And it allows then that sample to be representative. So what does that look like? Let's give more examples. So whenever we do research, specifically empirical research, right? It's not a case study where I'm sitting down and really observing somebody, but I'm doing empirical research, gathering data. We deal with probabilities. It's the expected relative frequency of a particular outcome. What is it that I expect things to look like? And the outcome is the actual result of the experiment. So then the probability becomes the outcome over all possible outcomes. So if I were to roll a dice, right, 6-sided dice, and I roll it 3 times, and I wonder what is the probability that I will roll a 1, well, what would that be?
Is there any way to predict that? Like to have an expectation of
Well,
that? Oh, 1 out of 6?
Right. So 1 out of 6, right? Because that's, so the predictive piece, I'm going to push off to a different time that we'll look at that. But when you're looking at probabilities and you're taking the outcome you're looking for, which is rolling a 1, you have to put it of all the possible outcomes. If there's 6 sides, right? It'd be 1 out of 6. Now, let's say I have 2 dice and I'm looking for the probability of getting a 7. Well, now all of a sudden I've got a lot more possibilities, right?
Yeah.
Because there's multiple ways I can make 7 with a dice, right?
Right.
1 and 6, 6 and 1, 2 and 5, 5 and 2, 3 and 4, 4 and 3. Okay, several possibilities out of the total. We're going to dive into all of that, but this is kind of where your brain needs to be going there with what we're discussing today. Okay, so when we do experimental research, we're looking at what is the chance that whatever result we got was in fact completely random, that it was just due to chance and it was not because there's a significant difference. That's what we know as the p-value, or the probability again of that. So in research articles, when you guys are seeing men and women differed in the number of pairs of shoes they own, kind of going back to the first day of class, and in fact, it showed a significant difference with p equals 0.05. that means we feel 95% confident, you flip it on its head, that the results were received and they're of sound measure, that it's not random. Or, turning it around, we think there's only about a 5% chance that that was due to randomness and error, right? Usually error is the term that's used. So that's pretty low percentage. So anything that has a p-value of 0.5 or less, we consider that to be statistically significant. That's the language we use. So again, if you're reading research articles and you see that p equals 0.05 or 0.01, that's telling you that the results the researchers got are very unlikely. It's very, very unlikely that they were just due to chance alone. It shows that there's actually something happening in the data. There's a relationship, okay? Have you guys all seen that, a p-value? Is that ringing bells for people? Yes? Okay, hopefully yes. Let's talk about it a little bit more. So more broadly, the range of a probability is 0 to 1, right? You cannot have a negative probability and you can't have a probability more than 1 because that equals like 100%, right? It's 100% guaranteed. You can't have more than that. So the symbols that are used is this italicized P. And again, this is usually how it's done, is P is less than 0.05. That's considered an alpha level. Again, don't get too bogged down with all the language, but this is what you are often looking for in research articles. So probabilities, specifically with these p-values, as it relates to normal distribution, is that, again, you are looking at a bell shape, distribution. So something that is normally distributed, and then the proportion, again, of randomness is that 0.05. That's a very, very small percentage. Okay. So we can see here, this is the relative frequency method, helps us to predict behavior. So you can see here the percentage of US adults who use each social media platform. So you see Facebook, Instagram, LinkedIn, and Twitter. And then it's divided first by gender, and then by age group, and then racial groups. But again, this is not it's not a full picture, but it gives you an idea of what it's like. So you see the breakdown for each and how that goes along, okay? So that helps us, again, to predict behavior once we have these percentages. This is the same thing. We can use this data to show, again, which is the most popular platform. Again, this is for teens this time around, and this is what they say they use versus what they actually say they use the most often. You go down that path. Okay.
Is there any way that you could maximize the screen you're looking at right now? It's just hard for me to see those numbers.
So the good news is you have all of these slides. They're in our class on, it's actually under the wrong week. I think it's for October 22nd, but this is sampling. Okay, let's see. Can I share with you guys where that is? Right here. Can you guys, what screen do you see? Do you see?
Course Connect.
Course Connect. Okay, good. It's right here, chapter 6.
Okay, thank you.
Yeah, sorry. I don't know why it does the screen so little here and not.
That's okay.
I wish that I could give you, wait, what if it's that? Is that better?
Yes, thank you.
Okay, but now I'm looking over here. Do you see my cursor moving?
Yes.
Ah, ask and you shall receive. Apparently I figured it out. So again, you can take a peek at that. This is just to demonstrate, again, user behavior when we're looking at different groups. This is specifically with social media use. So let's look at a specific example. Oh, that might be funky now. Did it move? Do you guys see relative frequency method?
Yep.
Okay. So this should look familiar to you guys, right? Here's a normal curve and we've divided it. Remember when we did the z-test, right? So this is for an entire population, as you can see, because that's how we see the parameters. That would be your mean, 1 standard deviation below and above. And we know that in that first standard deviation, plus or minus around the mean, that's about 68%, right? And then we add an additional 13 or so percent to each side. So 2 standard deviation from the mean plus or minus, we're looking at 95% of our, the data set falls in that category. So this is a particular example. Out of 200 teen girls, the average number of text messages that were sent in one day was 70. First off, can we just pause on that? Is that shocking to anybody else? That is shocking to me. That's a lot of text messaging. Okay, moving right along. It's not a judgment call, but so with a standard deviation of 10, which means what would be the band here? What number would be 1 standard deviation below the mean for this? Uh-oh. Did the internet go bad, or are we thinking or struggling?
Struggling.
Okay, so let's talk it through. If the average or the mean is 70 and the standard deviation is 10, what would be the number of text that's 1 standard deviation below the mean?
60.
60, yep, 60. Okay, what about 1 standard deviation above the mean?
80.
80, yes, Ada, good job. Okay, so how did Ada figure that out?
You just like add 10.
Yeah, you got it. That's exactly right. So we know, and again, this may be helpful for you guys when you're answering a question to draw out your normal curve, put the mean under, and then write that number down. So if we are given the information that this is 70, and I know the standard deviation is 10, then I just do minus 10, minus 10, minus 10. So that would be 70, 60, 50, 40, okay? The other way around, I just add 10. So this is 70, 80, 90, 100, okay?
So we'd be given the information that it's 70?
Yes, just like you were right here. Yep. So now the question is, what is the likelihood a random sample of a teen girl will text 70 to 80 times per day? Okay, so now I've been given this band. I know this is 70, 1 standard deviation above is 80, right? And because of the rules of a normal distribution, based on those rules, which we've talked about, I know that if I shade it in this band right here, which is the mean to 1 standard deviation above, I know that that is 34%. So what is the likelihood that a random person in my sample will have scored or will have texted 70 to 80 times? That likelihood is 34%. Okay, now question. What is the likelihood that a girl will have sent 50 to 60 text messages in one day?
$13.6, right?
Yep, you're exactly right. So how did you figure that out, Bree?
Between the 2 standard deviation and the -1 standard deviation, well, the -2 and the -1 standard deviation.
Exactly. So I know that this is the section I'm looking for, right? So then I know it's here. Okay, now, what is the likelihood that a girl will have texted more than 70 messages in one day?
Is it the same?
It's 15%, right?
50%.
Okay, so I've heard 15 or 50, 50 or 15.
I said 15.
Adding the top two. So
Ada,
15.
did you?
I
Sorry,
think 50 if it's above 70, because 70 is the average.
That's right. Okay, so the way I would do that is I go back here to my mean, which is 70, right? And I know that this here, I'm at the 50 percentile range, right? This is the midpoint, this is 50. So the chance that it's this number and more, it's gonna be this entire section, that's gonna be 50%. Now, if I wanted to count it, I could do 34.13 plus 13.6 plus 2.13. But really, I know that because this is my midpoint, it's exactly in the middle of my sample, 50% are going to be above and 50% are going to be below. Okay? Okay. Now, another one. What is the probability that a girl will have texted less than 80 texts per day?
$84.13%.
Okay, how did Kyle figure that out? So I figured, I'm going to assume here that you went to this one standard deviation above. This is 70, so this is 80. And now I'm asking for this entire area under the curve. I know this section is already 50, so then I just add this band to it. So it's 50 plus 34.13. Or you could do 100 minus 13.6 minus 2.13. Okay, questions about all of that? You got to be able to do all of this, kind of mixing it all up. There's going to be examples like that for sure on the exam. So review it and make sure that you know. And what it is you need to know here is the behavior of a normal curve. What are the percentages under the curve and how to get different bands, especially if given the standard deviation and the mean, you should be able to get all those percentages. Okay?
Yes.
Okay. It almost sounded like somebody took a picture, which is always a little scary. Okay, we're going to keep going. All right, random sampling. A sample that is designed in such a way to ensure that every member of the population has an equal chance of being selected. So this goes back to my convenience sampling, which we'll talk about in just a minute. With random sampling, technically, every person in the population has an equal shot of getting picked. So in psychology, do we use random sampling? Well, we try to is the goal, but we often end up using this convenience sampling, which is not a probability sampling. And we then randomize or randomly assign people to groups or certain conditions. Okay. The reason why that is if I'm trying to get a sample of Americans very broadly, right? But I work at a university, who am I usually going to use?
Your students.
Probably students or people who attended the university, right? That's just how it works. So because of that, we need to be really mindful. And then, because right away within my sample, that's not representative of the entire world or the entire country. So then you can do random assignment to try to introduce more randomness to it, but it's still not perfect. Okay, so let's talk about the different types too. First one is a simple random sampling. That's a design that's chosen to ensure that every member of the population, again, has an equal shot of being selected, and every combination of the members, again, has an equal shot. So if I give each student here at Aquinas a number ranging from 1 to 2001, and I randomly select a number from that group, and then I can, again, randomly select, but without replacing, right? I'm not saying, yep, take you, no, put you back, right? Because then there'd be a random shot, I would select you again. So we don't replace, and then I do that 30 times, I would have a simple random sample of 30 Aquinas students, okay? Now, the reality is this makes it sound like, I'm like, okay, everybody line up, you each get a number, right? It wouldn't quite be like that. It'd be in the registrar, you'd have a list, you'd know exactly the total number of students enrolled, and then you'd use a sample random number generator, which if you guys have you guys ever used those online? You can do a random number generator. They just pop. It's not like this, I do this for fun, but oftentimes if the kids are having like a competition, like which one is the best drawing? I'm not falling for that. I'm not picking one kid over the other. So random number generator, here I come. So you can find them online, they're readily available. So that is a simple random sampling. Everybody has an equal shot of being selected, okay? That's the best way to do it. Again, we should all strive towards that. Can you guys think of times where you might not be able to use this?
It'd be difficult to do it in a small, like when you don't have a lot of people to choose from. So if we're talking about like a tiny classroom, figure out if the teacher is good or something.
Well, that is true. If you've got a smaller sample or smaller population to begin with, then maybe you just do the entire population. But this can be really challenging if you don't have access to the entire population, right? If I don't have access to, so let's say I'm interested in everybody who's ever bought this pen and I want to know if this was a good pen, how would I know every person that's purchased this? Chances are I wouldn't, right? Now, or every person who has an O positive blood type. I may not have access to all that information, then that gets into privacy issue. So even though this is the goal, that is the most random way, and everybody has a fair shot of being selected, it's rare that you have access to everyone and then can truly randomly select, okay? And because of that, we've developed other ways that we can sample that are also pretty good. So one of them is a systematic random sampling. So that is a method of sampling in which every K number, so every random, you will select what is that number, that spacing or that gap. So every certain member in the population is chosen to be included in the sample after the first member of the sample is selected at random. And then after that, you just keep going down the list. So K ends up being your population size divided by your sample size. So if Aquinas had 2001 students, I want a sample of 30, I would divide that and I would then say every 66th or 67th student will be included in my study. So that would be a way to systematically randomize it, right? Okay, and what way do we see that in real life, this kind of systematized sampling? If you're at the airport, do you ever see this happen?
Oh, yeah. Random screenings. Oh, ding, ding, ding. You're the fun one to have to do all this stuff.
Exactly, right? Like, and why do they do it systematically?
So they can't have any blame of like, oh, they picked someone, you know, or because of race, or there's nothing. It's just
exactly.
There's no bias.
There's no bias. That's the key word. So when you systematize it and you say every 5th person is going to get whatever they check on your hands, right? Is it gunpowder residue, whatever they rub on you. And then every 10th person is going to get, you know, more of an X-race, I cannot speak, whatever the extra screening, let's just call it that. And maybe every 20th person gets their entire luggage searched through. You eliminate bias. You eliminate a non-random selection, right? This is still meant to be random, but you've just created a system around it. Checkpoints for DUI checks are the same, right? Because if they didn't have some sort of system, I mean, the first is, let's talk to you. Oh, there's like a cloud of alcohol that's just emerged from your vehicle. That may be a very good reason to then pull them over. But otherwise, I can't make it based on the type of car you drive or the driver or how many people are in the car, right? Like that would no longer be random and would, in fact, insert the possibility of bias, prejudice, stereotype, all of that. Okay, does this type make sense? Okay. Make sure you guys ask questions because again, we've got a test coming up next week and you guys are usually a fairly quiet group. I'll assume it's because my teaching is so abundantly clear that you don't feel a need to ask questions, but if you do have a question, know that you're probably not alone, so don't hesitate to ask it. Okay, so this would be the same thing. So if there's a population of 40 students and I want to have a sample of 8, I would do 40 divided by 8. I would know that every 5th person needs to be polled or polled to be participating in the study. So I would create a random number generator to select my first point, right? Which happened to be 4. And then every 5th person gets selected to participate. Make sense? Okay. So that is systematic random sampling. Next one is stratified random sampling. Okay. So that is when you divide the population into subgroups based on one, or sometimes it's more than one variable that is central to the analysis that we are doing. You then will draw a simple random sample from each of those subgroups. So for instance, if I'm interested in the behavior of Aquinas students, one way I could do that is, in a stratified random sampling, is divide them by major. So I have all of the students that are psych majors over here, those that are history major, those that are biology majors, and within those subgroups, I create a random sample. Okay, so what would be a benefit of a stratified random sampling?
You might only want to interview like a specific portion of the students, but still like have a random sample of that portion of students.
Okay, yeah. Let's say that the university, I'm interested in getting the university, and it was like 80% psych majors and let's make it less than that, but 40% psych, 20% math, 20% biology, 10% other. Based on those numbers, if I just do a random sample, what am I most likely to get?
Psychology.
Psych majors, right? Just based on the law of averages, right? There's more psych majors. So if I randomly sample, I'm going to get more of them. So if I want an equal voice for all majors, then I want to subdivide them and get an equal number for each. Can you see how this might be important also with issues of race, religion, marital status, right? So that you truly have a sense so that minority groups are not completely ignored or underrepresented, right? Okay. So again, if you do a proportionate that's like stratified sampling, and then to the nth degree, if you do a proportionate stratified sampling, you take a look at the size of the sample that's selected based on the proportion of that subgroup in the entire population. So you make it more relevant. So if you are in fact in a minority group, then your sampling of that group is also reflective of that. So if you decide you want to look at the state of Michigan and you divide it by race and you sample from each group, you would want it to mirror, right, the same as in the general population. So I can see here that if I have it represent the size of each subgroup that's seen in the state of Michigan, this is the breakdown, right? So out of 100 people that I'm pooling, right, that I'm going to sample, based on that, 79 should be Caucasian, 14 African American, 2 to 3 Asians, 0 to 1 Native, 3 to 4 multiracial. That would be then making it a proportionate stratified sample. So I'm having it mirror what I know to be true in the general population. Okay. A disproportionate stratified sample would be the size of the sample that's selected from each subgroup is in fact just disproportional to the size of the overall population. So if you're sampling from both, let's say, Caucasians and African American, but you want to have a 50-50 split, you would be deliberately oversampling from the African American group so that you have a divided sample that's more evenly distributed, right? So it would look something like this. This would be the entire population. You can see that white women over 50 is far more dominant, or it's a greater majority than Latina women or Black women. If I do a disproportionate stratified sampling, then they are all equally represented. So I would select 4 from each. Okay, questions about stratified random sampling?
So, which situation is it where you would want the population where people aren't like on the same term? Because like it seems like if you look at the data from the population that is proportionate, it would be pretty skewed in one direction.
Mm-hmm.
Sure.
Yeah, so again, it depends as to what it is I'm trying to find out. If I'm looking at behavior within the state and it's important for me to really get close or approximate the overall population, then keeping it within those realms might make a lot more sense, right? But if I'm trying to give an equal voice, and if it's more opinion-based, then making it a disproportionate might make more sense. Does that kind of add up? I'm worried that can you guys still hear me? Looks like people froze. Uh-oh.